Hey students, on this clip we're going to be going over how to simplify basic trig expressions using identities. Let's go over some examples. Now, to simplify each expression. Okay. All right. Number one. Let's say we have something easy. Let's say we have tan x divided by secant x. One strategy you can use is express everything in terms of a two-parent function, sine and cosine. So I know that tan is basically sine over cosine, and I know that secant is 1 over cosine. So I'm going to use that idea here to substitute the numerator and the denominator. Okay, so this numerator tan x I'll write as sine x divided by cosine x over the denominator is 1 over cosine x. Alright, so since we have a fraction over a fraction, I'm going to multiply the numerator sine x over cosine x by the reciprocal of the denominator, which is cosine x over 1. Because multiplying by the reciprocal is the same thing as dividing, alright? So just reciprocate the bottom and multiply by the numerator, okay? Alright, so the cosines cancel out, and you're going to end up with sine x. Sine x is your final answer. Alright, let's move on to number 2. Let's say we have cotangent y divided by cosine y. Alright? I like to express top and bottom in terms of sine and cosine. The numerator cotangent. Cotangent, if you have your identities memorized, cotangent is basically cosine over sine, right? Okay, so the numerator cotangent theta is going to be cosine y divided by sine y, and then divided by cosine is already one of the parent functions, so I'm just going to leave it as cosine y divided by 1. I'm expressing the denominator as a fraction because I want it to match the numerator. Alright? So whenever you're dividing two fractions, you multiply the numerator, the fraction as in the fractional numerator, by the reciprocal of the fractional denominator. So I'm going to rewrite the numerator as cosine y over sine y. That's the top. Multiply by the reciprocal of the bottom, 1 over cosine y. Okay? Now the cosines cancel out. Cosine goes here 1, cosine goes here 1. You have 1 over sine y. Oops, sorry, I meant to take the wrong color. 1 over sine y is basically the 1 over sine y. The reciprocal of sine is secant. So your final answer is secant y. Alright? So there you have it. Okay. Now, let's move along to question number 3. We're going to try and simplify cosine x plus pi divided by sine x plus pi. I'm sorry, sine x minus pi. Okay? Alright, let's try this one out. So, you just need to remember the whole idea that if you add pi to the cosine function, all you're doing is just shifting the period by a half, okay? So let's say you have, this is your cosine function, like this. So this is pi right here. If you actually go in the other direction. So this is your cosine function right here. It's a piece of it, negative pi. Cosine x plus pi basically means that this function gets shifted to the left. So the function gets shifted to the left. This will become your new x-axis, your new y-axis, right? So what function is this? This function that got created is basically the opposite of cosine, of the cosine x. And then for sine, if you have sine, this is your typical sine right here. Sine x minus pi basically means that you're going to be shifting it shifting sine to the right by x units. So if you shift sine to the right, this will become your new y-axis, right? And then what kind of function is this? This function that we're creating is basically the negative of sine x. Okay, so that's basically what brings about the whole identity that cosine theta minus 180 plus or minus 180 plus or minus 180 is basically the same thing as negative cosine theta, and sine theta plus or minus 180 is basically negative sine theta. Okay, so in this case, the numerator is going to become negative cosine theta cosine x, because this is just a half period shift to the right, which is equal to the opposite, and this one is half period shift. This is half period shift to the left, and this is half period shift to the right, and this is going to be negative sine x. Okay. All right. So what is this going to become? Minus over minus is a plus. Cosine over sine can be condensed into tangent x. All right. So there you have it. All right. Number 4. Let's take a look at this. What if we had cosine theta, tan theta, plus sine theta cotangent theta. Okay? Whenever I'm simplifying using trig identities, I like to express everything in terms of the parent functions sine and cosine, because every other trig functions come from these two. Okay? So this is good. I want to express this as in terms of sine and cosine. So I'm going to write cosine theta times tan is sine theta over cosine theta plus sine theta, and then I'm going to write cotangent as cosine theta over sine theta. Alright, so let's see what happens here. Let's put this over 1 so we have a fraction be multiplied by a fraction for the sake of consistency. So this cosine and this cosine cancels out, so you have sine theta plus, and in this area right here, the sine and the sine cancels out, sine theta plus cosine theta. And that's basically your final answer. It cannot be simplified any further, okay? Alright, so there you have it. Alright, let's move on to question number 5. Let's say we had sine A plus cosine A squared plus sine A minus cosine A squared. Okay, so to simplify this, obviously we have to multiply it out first, right? So if I multiply these two out, I can use the trick A minus plus B squared is basically let me write that lower here. A plus B squared is basically A squared plus 2AB plus B squared. And then if you have A minus B squared, it's basically A squared minus 2AB plus B squared. This is if you want to be lazy, you want to use shortcuts, you don't want to distribute and do all that stuff. You can use these two formulas to simplify the whole process, okay? So for this one, this is simply going to be sine squared A plus 2AB, because basically this is going to be my A and this is going to be my B. And then for this side, this is going to be my A and this is going to be my B, okay? So sine squared A plus 2 sine A cosine A plus cosine squared A. That's for the left side, and then for the right side, plus sine squared A. That's A squared minus 2AB minus 2 plus minus 2 sine A cosine A plus cosine squared A. Okay? Alright, so let's see what we can do here. If I combine sine A and cosine squared A, I can have sine squared A plus, actually I have a sine squared A here, and I also have another sine squared A here, so I can have 2 sine squared A plus, and if I combine this cosine square A with that cosine square A, I'm going to have this 2 cosine square A. And then we have minus 2 sine A. This one minus 2 sine A cosine A and plus 2 sine A cosine A are opposites. So they basically cancel each other out. So what can I simplify this into? I can factor out the 2 from both of them, and I have sine square A plus cosine square A. This is the Pythagorean identity, which equals 1. So you have 2 times 1, and the final answer is 2. Okay? Alright, let's take a look at another example, number 6. What if we had cosine of cosine to the fourth of theta plus 2 sine squared theta cosine squared theta plus sine theta to the fourth. What is this going to become? Let's see. What if we make a substitution here? Because it looks like this formula is similar to this one right here, only that is to the fourth power. So what if we say we have A be cosine squared theta, and let B be sine squared theta, okay? And then let's see what's going to happen here. So if we make that substitution, we're going to have, because cosine to the fourth theta is basically cosine squared theta square plus 2 sine squared theta cosine squared theta plus sine squared theta square. Okay? So this one I can now make my substitution. Whenever I have cosine squared theta, I put A, so we're going to have A squared plus 2 sine squared theta is B, and that's A. We can switch it around because multiplication commutes, plus sine squared theta is basically B squared. Okay? So what's the factored form for A squared plus 2AB plus B squared? There you have it. It's A plus B squared. Or you can do factoring by grouping to show it. So this one basically factors into A plus B squared. Okay? If you wanted to do factoring by grouping, this one is basically you're going to go A squared plus AB plus AB plus B squared. And then from the first you factor out A, you have A plus B. And then from the next you factor out B, you have A plus B. And you're going to have A plus B times A plus B, which is basically A plus B squared. Same thing. But if you use this formula, it's much quicker. Okay, A plus B squared. But to finish it up, we have to resubstitute our original substitution. So this is going to basically become cosine square theta plus sine square theta square. Wait a minute, isn't this the Pythagorean identity? Absolutely is. Cosine square theta and sine square theta is the same thing as sine square theta plus cosine square theta, because multiplication commutes. I mean, addition commutes, right? So this whole expression right here is just 1 square, because we know that sine square theta plus cosine square theta equals 1. And this is the same thing as cosine square theta plus sine square theta. That equals 1. So 1 square is 1, so that goes your final answer, 1. Alright? Thanks so much for paying attention to this presentation. Do subscribe to my videos so that you can be able to watch my upcoming videos.